Please notice the title of this lesson, Applying Theorems in Calculus. There are 4 theorems that you have learned so far. Intermediate value theorem, extreme value theorem, Rolle's theorem, and mean value theorem. You're going to have to keep them straight. It's really not hard, I promise. Now what we're going to do first is we're going to remember the definitions of each of the theorems, and I'll draw a picture because some of you are visual like me and I just need to see it. Does anybody remember, because it's been a while, remember intermediate value theorem? You got the right idea. You got the right idea. The intermediate value theorem says that if in 7th grade I was 5 feet 1, and in the 12th grade I was 5 feet 11, that there had to be some time between 7th grade and 12th grade that I was 5 foot 8. That's what the intermediate value theorem says. So let's see if we can write it up mathematically. There's one criteria for the intermediate value theorem. The function has to be one thing. Continuous. The function has to be continuous. And L is a number between f of A and f of B. Height is a continuous function. So my height is continuous from when I was in the 7th grade to when I was in the 12th grade. 5 foot 8 is a number between how tall I was in the 7th grade and how tall I was in the 12th grade. Then there exists a C on the open interval A to B such that f of C equals L. Now if you'd like, I will just, well, I'm going to anyway, whether you'd like it or not. I'm going to draw a picture to represent this that might help. Anybody need more help or need more time?
Yes.
Okay. All right. That's an L, yeah. L is a number between f of A and f of B. I don't know, I just wrote it that way.
But like you wrote it like twice.
Yeah,
Twice, so is there another letter that I don't
no, that's L. That's L. No, for heaven's sake. All right, all right. Okay. Here's A. Here's B. Here's f of A. And here's f of B. L is some number between f of A and f of B. What I know is that if this function is continuous and L is in between f of A and f of B, that there has to be some number C in between A and B so that f of C is equal to L. Just think about height. It might be helpful to some of you to put your theorems on note cards just so you have them to quickly practice. Extreme value theorem. Anybody remember what that one is? That's Rolls. Extreme value theorem says if a function's continuous on a closed interval, then by golly, there's a highest point and there's a lowest point. So, if f is continuous on closed interval a to b, then there exists an absolute max and an absolute min. Either at an endpoint or at a critical number. No, that's bad. At a critical number c on the open interval, where f prime of c is 0 or f prime of c is undefined. I knew it. A critical number is any x value where the derivative is 0 or undefined. That's what a critical number is. Sometimes I do have to look to make sure I write it up mathematically correctly. Remember, on extreme value theorem, your absolute max and min can be at an endpoint, or it can be any place between where the derivative is 0 or undefined. Okay? Let's draw a picture. I'm sorry, I keep looking at you in your ID. It is absolutely visible, and that is totally fine. It just makes me.
I got another ear.
There you go. Okay, so let's talk about this picture. You know what? I don't like that picture.
Don't follow along. I wasn't following on very quickly at all.
I like that picture better. This function is continuous from a to b. So we know that there's a highest point and a lowest point, and those can occur either at an endpoint or anywhere where the derivative is 0 or undefined, which could be right here or right here. Those are your only choices. Now, in this particular case, where's your absolute minimum? It's at A. Where's your absolute maximum? It's at C. But just remember, at an endpoint or at a critical number. Questions? So the only two criteria for intermediate value theorem and Rolle's theorem is continuity. That's all that has to happen is continuous. Now the two most recent, let's go to Rolle's. Do you remember how many criteria there are for Rolle's theorem? F is continuous on the closed interval. The same what? No, not A equals B. The Y values have to be the same, right? F is differentiable on the open interval. And the Y values of the endpoints have to be the same. If you can remember it, if you know it, no, I wouldn't write it. But if
No, like, I don't know. I just didn't know if you were gonna write it next to the sentence or.
no, I'm not going to rewrite that.
She doesn't want it.
Yes, f of a equals f of b.
That's real state reflexive.
Yep, that's a reflexive property, yep. Now, if these three conditions hold, then there exists a C on the open interval a to b such that, do you remember what? The derivative is 0. Good. Again, that's a fairly minor theorem because it's so specific. Picture? Anybody need more time to write? Okay. Don't erase. Yes, ma'am.
Is everything I do wrong?
I'm glad. I'm glad. Love the fingernails.
Oh,
Anybody need more time? Okay, let's do a picture. I have a function that is continuous on that open interval, or on the closed interval a to b. Is continuous on the, snap. It's differentiable on the open interval a to b, and f of a equals f of b. Why do those criteria eliminate pointy places? Because it's not differentiable at a pointy place, right? Now, so what we are guaranteed then is that there's at least one place in between a and b so that the derivative is 0. So in this case, there are 3 of them. Remember, a derivative equals 0 means the slope of your tangent line is 0. And we have one more. Mean value theorem. Okay. Here we go. Mean value. Did you watch the videos?
It didn't show it on the
okay, I have it.
So let's do mean value theorem. Do you remember the criteria for mean value theorem?
It has to be continuous and differentiable.
F is continuous on the closed interval.
Me and Catherine know what's going on.
F is differentiable
I think we deserve a reward.
on that open interval for doing what you're supposed to.
Exactly. We should have a party. We should. Or the day before Yes.
calculus.
The day before.
There exists a C on the open interval a to b such that what? Do you remember? Good. A rock equals I rock. Instantaneous rate of change, which is the derivative, equals the average rate of change, which is the slope of the secant line. I rock equals A rock. The biggest theorem in calculus of those 4 is this one. Talk about a picture. I need any more time? Okay.
Instantaneous rate of change equals average rate of
talk about a picture. The average rate of change, which is this line right here, the slope of the secant line, somewhere the slope of the tangent line will be the same as the slope of the secant line. This is the one that allows you to get a speeding ticket. Because if I know your average rate of speed from here to Tawnytown was 85 miles an hour, I know that there was some point in time on that trip where you were driving 85 miles an hour. Now there's one picture I think I might need to fix. I need to fix this extreme value theorem picture. I need to explain to you why. That function is not continuous on the closed interval a to b. There's one of the problems that you didn't ask me about on the homework that said you could not apply the mean value theorem because the function was not continuous at an endpoint. And the question that they brought up yesterday was, why is the function not continuous at an endpoint? Oops. So let me show you what this should have looked like. And this should have just gone on through. Do you remember the three-part definition of continuity? In order for a function to be continuous at a point, do you remember what they are? That's one of them. The function has to be defined at that point. The limit exists as x approaches that as x approaches that number from both sides.
Interruption. I think it's Lieutenant Cockrell, Candace Bowen, Sarah Porter, to the office, please.
Hang on just a second. If this one stops right here at A, there's no two-sided limit because there's nothing on the left. So this function would not be continuous at A, so the extreme value theorem would not apply. So we have to draw that on further. So now this function is continuous at x equal A by the definition. If you have any questions about that, holler at me when we talk about them. Can we do what now? This one? All the rest of this lesson is just applying those four theorems. That's all it is. Okay. Oh, it's working better today. The rate at which water flows out of a pipe. Now, look, this is a rate, okay? Does anybody want a highlighter? All right. The rate at which water flows out of a pipe in gallons per hour is given by a differentiable function, r, of time t. The table below shows the rate as measured every 3 hours for a 24-hour period. Let's interpret what these numbers are. If I look right here, this says at 6 hours, the water is flowing out of a pipe at a rate of 10.8 gallons per hour. That's what it means. At 21 hours after we started, or just say at 21 hours, the water is flowing out of the pipe at 10.2 gallons per hour. Use the words that are in the problem. So let's go to A. Estimate the value of r prime of 5, indicating correct units of measure. Please notice the word estimate. I can't figure out exactly what that derivative is because I don't know a darned equation. But I can estimate. Remember how you estimate a derivative from a table? 2 points where? Yeah, 2 points on either side. So what we're going to do is we're going to do this. We're going to say r prime of 5 is approximately r of 9. No, not 9. What do I want to use? R of 6 minus r of 3 over 6 minus 3. And you have your calculator because you're conscientious students and you know you need your calculator.
Always. Not get one.
All right, let's go. R of 6, 10.8 minus r of 3, 10.4. Okay? Huh? What's that give us? 0.4 over 3? Listen, if you multiply top and bottom of that by 10, what do you get?
40 over 30.
Not 40 over 30,
4.
4 over 30. 4 over 30 simplifies to 2/15. So the question now is what's the correct unit of measure? Now be careful. You're taking the derivative of a rate. So it's like I'm taking the derivative of miles per hour. So the derivative of this would be gallons per hour per hour. So, okay, if I'm taking the derivative, the measure here is gallons per hour per hour. I'm going to do the best I can. If you are driving, and you are driving 60 miles an hour, going from here to Tawny Town, and you realize, oh, I could speed up. Your speed is the first derivative because it's in miles per hour. But I decide to accelerate. Accelerate is the derivative of the derivative. You've had physics, right? So you know what I'm talking about. So you guys know what I'm talking about. So if I'm speeding up, then my speed, which was in miles per hour, is increasing at a rate of 5 miles per hour. So my speed in miles per hour is increasing. So it's miles per hour per hour.
You said the acceleration would be the second derivative?
Correct.
And speed would be the first derivative?
Right.
What would the original?
Position
Oh, okay.
would be your original function. Position. Okay. Those of you who have either had physics or are taking physics, when we get to position, velocity, and acceleration, that's all going to make. All right, let's go to the next one. Using correct units of measure. Shh. Explain what this, oh, okay, so it equals 2/15. Explain what this means.
It's flowing out of
At time 5 hours, the rate, I'm going to have to write this down, but I got to say it first. The rate at which the water is flowing out of the pipe is increasing by 2/15 of a gallon per hour. So the rate is increasing because r prime of 5 is positive. So we're going to say at time 5, the rate at which water is flowing out of the pipe is increasing by 2/15 of a gallon per hour. But on the AP exam, when it says you write that number with the correct unit, you're going to put gallons per hour per hour. Yes, you can put gallons per hour squared, but what's a square hour? What's a square hour? That was brought up at one of the courses that I went to, and most, at least math teachers, well, I won't say that, Many teachers prefer to use like per hour, because that makes more sense than per hour squared, because what's a square hour?
I like hours.
You absolutely can write hours squared. You can write that.
Like, wait, but how many hours?
Understand?
All right. Well, we're moving on. We're moving on. Using correct units of measure, find the average rate of change of R of t from 3 to 18. How do we find average rate of change? F of 18 minus f of 3 over 18 minus 3. There's no theorem, we're just working. F of 18, 10.7. F of 3, 10.4. Is that 0.3 over 15? Is that 1/50th? It's not asking us to do any explaining, but it is asking us to use the correct units of measure. I found an average rate of change of a rate. The rate itself was in gallons per hour, and if I find the average rate of change of that, what's my unit going to be? Same thing. If I find a rate of change of a rate, it's going to be so. Now, yesterday I had some students asking me, wait a minute, why did you do the same thing here and here, but on the second one I was finding an average rate of change, and on the first one I wasn't finding an average rate of change? Because on the first one I'm estimating a derivative. And that's how you estimate a derivative when all you're given is a table. So the first one is an estimate, okay? Let's go on. I believe we're on C. If you have a highlighter, you get it out. Is there some time? When you see anything like that, is there some time? Would there be a time? Is there a value? What that screams to you is use a theorem. Do you notice it doesn't ask us what t is? It just says, is there a time? Now look at the information that we're given. We want to know this. What theorem would fit that? Rolle's theorem. So when it says, is there some time between 0 and 24 such that r prime of t equals 0, we're saying, does Rolle's theorem apply? If Rolle's theorem applies, the answer is yes, there is some time. If Rolle's theorem does not apply, we say, well, there's not a time guaranteed. What are the criteria for Rolle's theorem? Is this function continuous? Aha, this function is continuous because this function is differentiable. So f to r is continuous. And remember, the continuity is on a closed interval, so we'll just put that. R is differentiable on the open interval 0 to 24. If we're going after Rolle's theorem, we've got one more criteria. What is it?
R of 0 equals R of 1.
Does R of 0 equal R of 24? Yes, they both equal 9.6. R of 0 equals R of 24. They're both 9.6. So by Rolle's theorem, there exists some, did it say find a t? On the open interval 0 to 24, such that r prime of t equals 0. Now remember, those theorems are existence theorems. They tell us that something exists, but they don't tell us what it is or how to find it.
But we don't need it.
We don't need to. That was not asked on this question. In fact, we couldn't because all we're given is a table. Tell me if you have questions, all right? Let's go on. Some of you will most likely study business. Business is a very popular major. Is this somebody's lanyard? No. One of the things that you want to do in business is minimize your cost and maximize your profit. Let's take a look here. The total order and transportation cost, C of X, measured in dollars, of bottles of Pepsi, I don't like Pepsi, is approximated by that function, where X is the order size in numbers of bottles of Pepsi in hundreds, so hundreds of bottles. What if X was 2? What does X equal 2 mean? 200 bottles. And if I let X equal 2, and I work through that expression, then that would tell me the total cost of 200 bottles of Pepsi. Total order and transportation cost. All right, so let's look at part A. Is there a guaranteed value of R? What's screaming in your head? Theorem! Theorem! It's a theorem. Not run. That's not what I want screaming in your head. It's a theorem such that the average rate of change of cost is equal to C prime of R. What theorem? Why mean value theorem? Yes, because it's where the average rate of change equals the instantaneous rate of change. So, mean value theorem. We have to decide, does mean value theorem apply? Is this function continuous on the closed interval 0 to 3? First of all, I want you to look here and decide, where is this function discontinuous? What's not in the domain? -3 and 0. Is this function continuous on 0 to 3, the closed interval 0 to 3? No, because this thing's not even defined at x equals 0. So you're going to say this: C is not continuous at x equals 0. So mean value theorem does not apply. There is not a guaranteed value. You got to answer the question, and the question was, is there a guaranteed value? There is not a guaranteed value of R on 0 to 3 such that I rock equals A rock. It might be there, but it's not guaranteed. Answer the question. Okay? Got one more part on that one. Is there a value of r on the closed interval 3 to 6 such that c prime of r equals 0? Give a reason for your answer, and if it exists, find it. Okay, we're right here. What's that tell you to do? Theorem. What theorem? Why rolls?
There's a 0 rolls.
Because that's in Rolle's theorem. That's in Rolle's theorem. Okay, what does Rolle's say? What are your criteria? Is R continuous on the closed interval 3 to 6? Why? Because the only places the thing is discontinuous is at 0 and negative 3. So we know R is continuous on the closed interval 3 to 6. Is the function differentiable? Let me say something here. We're going to have to take the derivative in a little bit. But what I'm going to tell you is by looking at this, you can tell that it's differentiable because when you take the derivative, this is going to stay in the denominator and so will this, and you'll see that in a minute. But the only places that's a problem is at 0 and negative 3, which are not on the interval. So we know R is differentiable. What's the last criteria for rolls? Does C of 3 equal C of 6? That's what we got to figure out. You got a calculator. Now listen, on your calculator, I want you to do this. I want you to put that and y1. Please go to table set. No. Go to window. Oh, I could have gone to table. Yeah, fiddle. Go to table. Go to table and find what C of 3 is and find out what C of 6 is. What are they? Okay. What? 8?
8,300.
So Rolle's applies. So Rolle's theorem guarantees. Remember, what does Rolle's theorem guarantee? There exists a value C on the open interval 3 to 6 such that C, is it R prime of C equals 0. Now it told us to go find it. Now listen, your calculator, you're going to make it talk to you today. You get that calculator. In your Y2, do you have Y2 equals you keep that in your Y2. To do this, this is alpha F4, alpha trace.
Oh, is it math 8?
Math 8 will be your derivative. Keep that in your calculator.
What did we say? Wait, a question.
Yep.
So the question said, is there a value R on the interval, the closed interval 3 to 6? But we this value R here, 3 to 6, is that set?
No. Now, remember, this is what we're looking for, correct? So, don't graph the original function, graph the derivative. But how do you want to set your window? 3 to 6. So on your window, let your x values be 3 to 6. Then I want you to go find that 0.
So R equals,
Well, it's not r, is it? Yeah, oh, sorry, it is. So what would that r equal? 0 what? 098? Let's see, what was the question? If R exists, find it. So we did. We found it. No, you do not have to show work, because that would definitely be a calculator problem. We have one more question on that one. For 3 to 9, what is the greatest cost for order and transportation? Can I do that? Extreme value theorem. What is the requirement for extreme value theorem? Continuity. Is that function continuous from 3 to 9?
yes.
Sure is. So, C is continuous on, that looks, I don't even know what that looks like, on 3 to 9. So by EVT, there exists an absolute max on that closed interval. I could have written absolute max and min, but this problem only was asking for the greatest, so that's why I only wrote absolute max. Find it. Where can extreme values occur? Endpoint, so I'm going to find C of 3, and I'm going to find C of 9. And where else can an extreme value occur? Which happened to be the only time that this derivative was 0 was at that 4-point thing that y'all got just a minute ago. And I erased it, so I can't remember what it is. 4 point what? 098.
Because we didn't check what happens between 6 and 9. So when we have to go back and check
Check what?
that there isn't another value between 6 and 9 that we didn't see. Because our window before was just 3 and 6, and it didn't go again tonight.
That's no problem. That's no problem.
But like, if it's something at like 7.4 that we wouldn't know about.
Remember, where do extreme values exist? Either at the endpoints or anywhere where the derivative was 0 or undefined.
Yeah, but like,
So,
the derivative of 0 between 6 and 9.
oh, I see what you're saying. I see what you're saying. You're right. We need to see if that derivative equals 0 anywhere between 6 and 9. You're right about that. So that's my bad. So, go back and graph your derivative again, but I want you to change your window 3 to 9, not 3 to 6. Because we need to check that whole interval 3 to 9. Were there any others?
No.
There weren't any others? Okay. So these are the only 3 possibilities. You can use your table or second calc value for 3 and 9. I'd use the table. What's C of 3? 8? Was that the and the 1/3? What's C of 9? 8, 6, 11. At point 11, 11, 11, 11, 0.1111, that's yeah. Thank you. That's 1/9. You're going to have to do second calc value on that one. But remember, you're doing that on the function, not on the derivative. .67. Give me 3 decimal places. 672. The question is, what's the absolute maximum? What is the greatest cost? So you're going to say the greatest cost on 3 to 9 is $8,333, and you're going to have to change that to cents. I'm an idiot. $8,611.11. Thank you. I'm having moments. I think I'm getting part-timers. Yesterday we used too much time going over homework, so we didn't even address this problem at all. They have to address it on their own with the notes. So what I'm going to do, I want us for sure to be able to work this one, and then we can go back to that one because I think we'll have time. This is on the last page. The functions f and g, come on, f and g are both differentiable for all real numbers, and g is strictly increasing. What does it mean for a function to be strictly increasing? It means it's increasing all the time. Not necessarily, not necessarily. What does it mean about its derivative? The derivative's always positive. That might be of help. So I would write that right here. The table above gives values of the functions and their first derivatives as selected values of x. The function h is given by that thing. Oh my goodness, I see a composition. Now, one of the things, oh, this is a two-bagger already, okay. One of the things that Sparks does is he builds in a whole lot of review, and that's what you can see coming right here. Write the equation of a tangent line. When you have to write the equation of a tangent line drawn to the graph when x is 3, what do you have to know to write the equation of a tangent line? Hot and soft. I already know something about the point of tangency. I know what's 3. X value is 3. How would I figure out what the y value is? So we need to find h of 3. Well, that's f of g of 3 minus 6. Well, what is that? -7. Yep. G of 3 is 4. F of 4 is -1. And -1 minus 6 is -7. So we know the point of tangency. How do we find the slope of the tangent line? Take the derivative. Oh my goodness, how do I take the derivative of that thing? How do you take the derivative of a composition? Peanut M&Ms. Yeah. The derivative of the outside. So it's, no, f prime of, remember you haven't eaten the inside yet, times the derivative of the inside. Remember, you eat the outer shell, and then you eat the chocolate. Gentlemen? What's the derivative of -6? 0. So what I need to find is h prime of 3, because I'm doing this at x equals 3. So it's f prime of g of 3 times g prime of 3. Let's figure that out. Did you get? That's what I got. Anybody getting 6? What is 6? The derivative, aka the slope of the tangent line. Right, SOT. So we can write our equation of our tangent line, y minus y1 equals m times x minus x. Jeez. Equals m times x minus x1. You all right? Let's go to B. Find the rate of change of h for the interval 1 to 3. Am I finding I rock or am I finding A rock? Which one? A rock. Why? Because it's over an interval. Good. So I'm doing h of 3 minus h of 1 over 3 minus 1. Well, I know what h of 3 is. What's h of 1? H of 1 is f of g of 1 minus 6. All right. G of 1 is what, 2? F of 2 is 9. 9 minus 6, 3. You got 3? Yep. That's the average rate of change over that interval. That's all it's asking. Yeah. Let's go on to C. Am I going too fast? Explain why there must be theorem. A value for r on r equals, or between 1 and 3 such that h of r equals 2. Which theorem? Why do you think IVT? Ah. Do you notice that that has nothing to do with the derivative, does it? Nothing to do with the derivative. Let's go to IVT. What are the criteria for intermediate value theorem? Is that function continuous? How do we know that? Because the function is differentiable. Now, I want you to understand, we were told f and g are differentiable. Does that mean h is differentiable? Yes. So, h is differentiable. H is continuous because f and g are differentiable, therefore continuous. Now, what else do we have to do about intermediate value theorem? Yeah, so I got to find the y values for r equals 1 and r equals 3. What's r of 1 and what's r of 3? Now r of 1, h of 1, what the crap is that? I don't know. I don't know. H of 1 and h of 3, I don't know. Thank you. H of 1 is 3, you said? And h of 3 is negative 7. Is this y value we're looking for between 3 and negative 7? So you're going to say h of 1, let's start with h of negative 3. No, 3. H of 3 is less than negative 2, which is less than h of 1. Do I have that set up right? H of 3, negative 7 is less than the y value we're looking for. Yep. No, put the value that you're dealing with. Okay. So by IVT, there exists a value C on the open interval 1 to 3 such that f of C, I don't want f, do I? If we're going to get technical, I'll do it this way. All right. We got one more question on this one. Is it? Explain why there is. Explain why there is. That screams theorem. Why there's a value of C on the open interval 1 to 3 such that h prime of C equals 5. Now, is that intermediate value theorem? No. Is that extreme value theorem? No. Rolls? No. That means mean value theorem. What in the world mean value theorem? Now, when you get to this point and you say, well, that means it's got to be mean value theorem, but I don't understand. Let me show you something. I want you to do this. What is h? What is h of 3 minus h of 1 over 3 minus 1? Is it? Oh my gosh. That's average rate of change. That's instantaneous rate of change, right? A rock equals I rock. So what we've got to do is we've got to show that the mean value theorem really does apply. What are the criteria? H is continuous on the closed. So by mean value theorem, there exists, what's it asking for, a C on the open interval 1 to 3 such that h of 3 minus h of 1 over 3 minus 1 has to equal h prime of C. So 5, what was it, negative 5? Is that what we said? Tell me how far. Okay. Now let's go back to the second to the last one. A car company introduces a new car for which the number of cars sold, S, is modeled by that function where T is time in months. Find the value of S prime of 2.5. How are we going to do that? Okay, so we could do this two ways. We could actually by hand find S prime and evaluate that at 2.5. Could we use our calculator to do it? How? Yep, put this in Y1. And then you want the derivative, which you should have in Y2. Anybody getting a number? Okay, 133.333. Using correct units. Explain what this value represents in the context of the problem. Look right here. This is the number of new cars sold. And the time is in months. Well, did we take a derivative of a rate? No, this was not a rate. This was just flat out number. So when we take a derivative, what that's going to tell us is the rate at which the cars were sold. So what this says is at 2.5 months, new cars are being sold at a rate of 133 per month. So at time equals 2.5, the number of cars sold how do we want to say this? The number of cars sold, the number of cars, I don't want to say it like this. I don't want to say it like this. Cars are being sold. That's better. Yeah, sorry about that. That's how I want to say it right there. At 2.5 months, cars are being sold at a rate of 133 cars a month. Ready to go to part B? I don't know if we'll finish this. We'll see. You can handle these two, though, if we don't get them finished. You can look on the notes that I'll post, and I promise I'll get them done. We won't have a tornado today, so we'll be okay. Find the average rate of change of cars sold over the first 12 months. How do we do that? F of, is it F? S. That's what I'm trying to think about. Is it 0 or 1? It's 0. Yeah, it's 0. Because 0 meaning no time has passed. So S of 12 minus S of 0 over 12 minus 0. Use your calculator and crunch those numbers, but you've got your Y1. That's what Sparks says, so you tell me if he's right or not. Let's just talk through what that means. Correct units of measure, and what does it mean? Remember, this is an average rate of change. Over the first 12 months, cars are being sold at a rate of 96 cars per month. No, over the first, you can, over the first 12 months, so let's word it this way, Ava. Cars are being sold at a rate, at an average rate of 96 cars per month. Please go through that last problem. It will be on the answer key that I post.